Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 21, 2025, about 7 days ago. The standout finding is that established interpretability tools reveal where repetition hallucinations originate inside encoder to decoder cross-attention, and simple probes can even flag hallucination risk and speech versus non-speech directly from decoder signals. The paper is titled, Beyond Transcription, Mechanistic Interpretability in ASR, and the implications for model transparency and targeted debugging are quite significant. Beyond repetitions, the study shows rich acoustic layers that linearly encode speaker traits and semantic categories, plus delayed token commitment dynamics across decoder layers. So the last segment highlighted how encoder interventions affected contextual bias. Figure 1 shows average linear probe accuracy across encoder layers for semantic classification, which means a simple linear model reads semantic categories directly from encoder activations. Accuracy rises modestly through mid-layers, then climbs sharply at the deepest layers, reaching about 86%. This pattern suggests semantic representations accumulate gradually and concentrate near the final encoder stage, so the encoder carries more than acoustics and can separate meanings increasingly well. Alright, the semantic rise just now set the stage for causal tests. Table 1 reports acoustic to contextual patching with white noise disruption, and it shows substantial error recovery for both Whisper and Qwen2-Audio. Encoders restored accuracy more often than decoders, which signals that semantic bias lives inside the encoder and can be counteracted. The higher restoration fractions also imply practical interventions that selectively nudge encoder states during inference. So the table just summarized restoration effects. Figure 2 shows semantic classification accuracy across encoder layers for several category pairs. The curves rise from around layer 18, dip slightly near 23, and then climb steadily, crossing 80 to 90% by the final layers, which indicates strong semantic separability. The mid-layer lift suggests that semantic structure already forms before the top layers, so linear probes can decode, meaning well ahead of the encoder's end. This trend supports the claim that encoder states carry semantic expectations that influence decoding. Alright, the last figure traced semantic separability across encoder layers. Figure 3 shows how token choices evolve inside the decoder. Panel A plots the probability of the finally selected token by layer and marks stabilization around layers 25 to 27. Panel B reports phoneme error rate, which is a measure of acoustic mismatch, dropping notably after layer 25. Panel C presents semantic cosine similarity among top candidates, rising later and higher for Whisper, which means candidates stay more semantically aligned as commitment nears. Wrapping up, 2 takeaways stand out. First, encoder states carry strong semantic and quality signals, so simple probes and light interventions can predict and reduce hallucinations in real time. Second, repetition loops trace to specific cross-attention heads, enabling targeted fixes rather than blunt model tweaks. Thanks for listening. I am Alex, and this was the AI Research Roundup.